Hello everyone, welcome to this session. This is the last session of this week, and we will talk about the MATLAB implementation of the simple linear regression and KNN. So let's start from the simple linear regression, right? We use the data set of the traffic accidents data set. This is a built-in data set in MATLAB according to the US traffic accidents and fatalities in 2004. So in total, it has 51 samples. And our goal is to build a relationship between the population of the states and the number of fatal accidents. So intuitively, these two are related and is a linear relation. So we can say the data set is here. Traffic fatalities, this is Y we want to predict. The total population, this is numbers, and this is X, which is the input, right? So now we can first load the data. So these are the built-in data in MATLAB. So you can load the data here. And then we select the necessary data, the population of states, and the accidents, the fatal ones per state. So X and Y are prepared. Then we can do two kinds of linear regression. The first way is we do the linear regression without intersect. So the MATLAB implementation, we can see is like this. A1 equals to X backslash Y. So remember, this is not divide, this is the opposite direction. So backward slash. So this operator is a MATLAB command to perform a least square regression, right? So using this, we can get the coefficient A1, and we get the relation is Y equals to A1 multiply X, right? So for more details, you can see the live script. Then we can see that how the A1 is predicted and what is the result. So we can see that we first calculate the Y calculate 1, the Y value based on A1 equals to A1 multiply X. Then we can scatter XY, it means to put the points in circle to the figure. Then we can compare the line and the points. So we can see the result is here. So we can see it's let's say a reasonable fit, right? So this is implementation of linear regression without intersect. But sometimes we do want the intersect. So how to do it? So first, we need to make the X into the correct length. So first, this is X, we put it here, and in front of it, we put it with ones. So we can say ones length X1, right? So we put the length here. And B equals to X backslash 1. So B, this is a vector. So this vector includes two things. So first is the coefficient, and then the intersect. So we can see the prediction and visualization. So we can calculate the Y, calculate 2, X multiply B, then we can compare with the previous one, as we can see is here, right? So this one is the old one, this is the new one. One with intercept, this is with intercept, and this one without. So we can see this is a linear regression model. Consider the intersect. The next one is a KNN. So we use an example, we call it the iris flower classification, right, problem. So in this one, we have the X have 4 dimensions. So these are the input features. We have the sepal length, the sepal width, the petal length, the petal width, right? So we have 3 classes of flowers. These 3 ones, right? So we want to know that for a new point with the following features, which category does it belong to, right? So we can see here are the features and the labels. Now we do the classification. We have the number of samples of 150 data in total. So each one, we have the separate features for each of them, and we have a category of it. Right. So now what I will do is to implement KNN through MATLAB. First, load the data. Right. This is also built-in data. You can follow this one, load the feature, iris. Then you can get X and Y. Then I will split the 150 samples to the training data and or what we call the example data and the query data. Right. So we can see use a randomly split data set. We use a function called randPerm So you can check it on Google to see how this function works, right? So this one generates a permutation, random permutation of a certain length y, right? So the numbers. So we can see we generate two random permutations. It means that we pick the first 100 of them to be example data and the last 50 to be the query data. So then we can see how we do the KNN model. So in MATLAB, there is a built-in function. We call it a fit-C KNN built-in function. So this function will help us to provide us a KNN model. And the syntax is the first argument, example X, example Y. Now we have the neighbor, the number of neighbors is a K. So this K is I set K equals to 5 here, and you can set other values. So after this command, we have a model. So this model is a KNN model, right? So this KNN model can be used for prediction. So we can now we predict the first 3 samples. So we can see the predict function. Predict model, the inputs are the query X, the query data, the 1 to 3 row, all the columns, right? So this one, using this, we can predict the label predicted, so that the output is here, right? So you can see the live script and find out yourself. So that's all for this session. So now we will go to the quiz and assignments. Okay, thank you very much for listening. Thank you very much. Bye-bye.